let's try to build an application, okay, and then run it on a Spark cluster. On a Hadoop cluster. Okay, so for building a Spark application, we saw how to do that, right? So we first need to build a Maven project. Okay, so and in our previous session, we actually configured how to build this project in Eclipse, right? So we configured Eclipse to do a Maven build. So and then we have created a project here. Now within this, we created a package which is reflecting the IDs that we gave, the group IDs and the artifact IDs that we gave in the pom.xml file. So if you all recall this, so this pom.xml has your build configuration to basically pull all the include all the Spark dependencies. Then you create a package with the same name as that group ID and the artifact ID. Okay, and within that, so we have a package called org.test, which is the group ID, and Spark, which is the artifact ID, and we created a package. And within that package, we are creating a Scala object, which becomes your Spark application, right? So that's how we started off in our previous session. So now let us actually build this application. So I'm creating a Scala object called as word count, okay? And within this, now let us build a word count object, okay? Let's build a word count project. So this word count Spark application is to take a word file, take a text file, and basically try to identify the distinct words, as well as the number of times these distinct words are repeated in this text file, right? So let's build such kind of an application, right? So now we have done this in the Spark shell. Okay, now in order to build an application that we can launch it on an Spark on a Hadoop cluster, so we need to create an independent application. Okay, so therefore we are built this Maven project. Now the first thing that you need, see, when we are working in the Spark shell, the Spark context object was available in the Spark shell, so you didn't have to create that, right? But in this case, we would have to have a Spark context object created ourselves, right? So the first thing that you need to do here is, first of all, make this as an executable file. So we will include a method within this application, the main method, so that this becomes executable. So I'll say define main, which is going to take some arguments here. So it is nothing but an array of strings, right? So whatever the parameters you are passing to this to this application, so that is collected as arguments to this program. And I say so here the first thing that I need to do is, since this is an independent application, we need to create a Spark context object, right? So to create a Spark context object, the first thing that you need is a Spark configuration. Okay, so I'll say val conf equal to new. I'll create a Spark configuration object. Okay, so this Spark configuration object is not defined. Okay, so I'm going to import this. So I'll say import org dot Apache dot Spark dot, I'll include this Spark conf object, right? So this is a Spark conf object. So I'm including that Spark conf. Now, once you have the Spark conf, now we want to set some properties. So the configurations that you're using with which you are going to create a Spark context object has to be set here, right? So here I will say set app name, right? So set app name is one of the functions of the Spark configuration object where we specify the name of the application. So the name of the application, I will call it as word count application. Okay, and also I'm going to set, I'll say set master. See, the set master object is the one which specifies how are you, or rather, which is the cluster manager that the Spark context should connect to. If you are running it on a cluster, you'll have to specify the cluster manager, right? So otherwise, you can specify this as local. So first, let us run this in local mode, and then we will run it on a cluster mode, right? So when I say local, it is not running on any cluster. So it is running on local mode. We are setting some configurations for the Spark context, configuration object. And the next step is I'm going to create the Spark context, right? So I'll say val sc is equal to, I'll create a Spark context object, okay, by passing the configuration that we have created here, right? So that is nothing but conf. Okay, and you can see here the Spark context is not available. So let's include Spark, import the Spark context also. So I'll say import org dot Apache dot Spark dot, now I'll say Spark context. So this should be fine, right? So now I'm creating a new Spark context object, right? So by passing the configuration. So now we have Spark context, for this application. Now, since this is an independent application, we are not hard coding. So what we'll do is we'll pass the input file that, the input file from where you need to do the word count as an argument to this program, right? So when you pass this as an argument to this program, So that would be part of this arguments array which you are passing to this main function, right? So now I'll use that file and I'm going to create an RDD out of it. So I'm going to simply say my arguments variable here, which is parameter to this main method. Now that takes the arguments to this program. So I'm going to take the first argument, which has the file name using which I want to create an RDD, right? So this I will just default it to minimum, right? So arguments of 0 is the file name. So I'm going to just take that file name and create an RDD here. So I'll say, first of all, I'm going to use the flat map method, okay? So you can see all the different methods that are supported by RDDs. So I'll use the flat map method to basically break this, each record of this RDD into, each record is basically a line. So I'm going to break this line into individual words, right? And I'll use this flat map method. So you can see a flat map method here. So I'll use the flat map method. So the flat map method actually takes a function as an argument, right? So here it is asking, so it is, you need to give a function here. So I'm going to frame this function. So I'll say, line, okay, take every record as a line here, okay. So I'll just make it this way. Take every record as a line, okay, and I want to basically split this line into individual words by specifying the delimiter and how to split this. So I'll say line dot, now I'll say split, right? So line is basically, see, automatically it gets this, right? So line is a string, okay, because the input to this is a string, and then I'll use the split function, okay. So I'll say split based on the delimiter space, right? So I am passing in a function to this flat map method where the function takes every record of this test RDD, which is nothing but a line of text, and it returns line dot split with spaces. So by splitting the data, splitting each line with space as the delimiter, so that you get individual words. This is something that we did already, right? And then the output of that, right? So the output of this flat map method is an RDD of strings. So on that RDD, I'm going to use the map method, right? So this is just writing everything, multiple steps into one, one line. Okay. So the output of this flat map is nothing but a RDD of text. So I'm going to take that RDD and I'm going to attach 1 to everything, right? So I'm going to pass a function to this, okay? So I will just say map, okay? I'll take each word and I'm going to return word, comma, 1. Okay, so this, I'm mapping this function. So this function takes every record of this resultant RDD, which has individual words, treat everything as word, and then return word, comma, a number 1 attached to it. So the result of this map function is basically an RDD in which each record has the individual word followed by 1 with it, right? And then the resulting set, the reduce by key is something that we, again learnt in our earlier session, right? So it is going to do the aggregation based on the keys, right? If you recall that. So it does the aggregation based on the keys and applies this whatever the operator we are passing here. So I say, take the first parameter and add it to the next. Uh, so I say underscore plus underscore. So it takes the first two, key value pairs from this, the result of this map function. So, and then it compares the keys based on keys. It takes the first and the second, and then just aggregates the values, right? So it does this consecutively and thereby aggregating the count of the words. Okay, and next, I will simply say the result of which, okay, result of this reduce key, okay, based on the keys, right? So it's the result of this would be basically the distinct words and their counts, right? So I'm going to use the save as, okay, save as text file, okay, save as text file method of this um, RDD, okay, of the resultant RDD, and so that it would write this results into some folder, okay, and that folder name we are specifying as an argument to this program. So I will say save as text file and pass the arguments to this program. So that is the second argument to this program, okay. Okay, so I reference it as 1 and I close this, right? So now in this one line, I have 1, 2, 3, and 4 steps combined into one line, right? So this is how, this is how Scala allows you to write a highly simplified and, short code, right? So basically, I'm taking every line of text as and then I'm applying the flat map function to basically split the line into individual words, and then output of that is an RDD, and on that RDD I'm calling the map method to basically attach 1 to every word, and on the resultant RDD, which is nothing but an RDD of word that is a string and an integer. So I'm using the reduce by key method to basically aggregate, the words with the same keys. Okay, so you have distinct words and the total counts of them. Okay, and then I'm storing this output into some folder which is passed in as a argument to this program. See, I can also write this, if you recall our previous session, okay, see, I can write the same code by saying something like this. So I'll say words RDD. I'll just copy this line, right? So right now, I'll create another. I'll say um, val see, this code is equivalent to this code, right? So instead of see referencing see the output of this, okay, so the output of the test.flat map, now I'm storing it in words RDD, right? So now on this words RDD I'm applying the map, and the output I'm storing it in words with one RDD. It's a different name I'm giving, right? Now it is the same thing as just doing it like this, right? So what I'm saying here is I perform a flat map on this test RDD, okay? The, the resultant RDD on which I'm applying this map function. So I'll just put this, I mean, like, this is the same as, right? This is another way of writing this is simply like, say test dot right? So if I just put it in a single line, right? So you're applying the map on the result of this, right? So it is just like this, right? So here, it is like you first call the flat map, and the result on the result of this flat map, you use the map function, and on the result of that map function, you use the reduce by key, and on the result of that reduce by key, you apply the save as text file. Okay, so I'm just putting it in this order so that it is more readable. So all this three is just is the same thing. I'm just performing these operations. So instead of writing it this way where I'm just creating other RDDs, I'm just calling this all in one line. So when you see the dot here, you should always read it as you're taking the output of the previous operation that you have performed, and on that output you are calling this function. So the result of this test.flatMap is an RDD with strings. So I'm taking that RDD with strings. It is unnamed here. So in this case, I'm just naming them, right? So I'm naming every output here so that it is more readable. Now here, I'm not naming them. That's the only difference. So I'm just going to remove this stuff. Okay. Now I'll just add this comment here. I'll say so this is same as what we see here, right? So this and this are same, so I'll just put this all into okay. Initially it may look little confusing, but once you start using it, then it makes more readable. Now for building a flat jar file out of this, right? So you need to just save this application. So I'll just say save this, right? So now we have saved this word count.scala, and so we need to make sure that we install Maven in our machine. Okay, I think when we installed Hadoop, we didn't install Maven, so we can do that now. So we can to install Maven, the command is very simple. Apt get install Maven 1 2 3 4 5 6. So I'll say go ahead and continue. I say yes. Okay. So now we have installed Maven on this machine. Okay. So the next step is go to this location. This is where you can see there is a pom.xml file for this project, right? So what we need to do is we need to just give the maven command. So that is mbn clean package, right? So if you say mbn clean package, now this will build a jar file and will place it in this target folder. Okay, so this is the target folder for this project, and we would find a jar file in this target folder. So that is going to be the jar file for your Spark application, right? So I'm going to say mbn clean package. So this is called as a fat jar because this is an independent Spark application. So all the Spark dependencies will be included into the project itself so that you can run this on any machine. Excellent. So you can see here, now we have successfully, built this. Now, if I go to the target file, target folder here, okay, so you can notice that there is one, the snapshot jar with dependencies, right? So this is your project file. This is the jar file that the Spark the jar file for the Spark applications, right? So now you have created a the Spark file. So this jar file we can now execute it on a Hadoop cluster. So now you can execute this on a Hadoop cluster, right? So let me open another terminal here, and now let me see if all the Hadoop services are running. So Hadoop services are not running yet. Okay, so let us start the Hadoop services. So I'll say start dfs.sh. Okay, very good. So I have all the 5 Hadoop services up and running. Let me go to home. Okay, so the name of the class is, let me see what is the name of the class here. Name of the class is word count. So I'll just keep it as that. So let me just do this again. So I'll say Spark submit classes org dot test dot spark dot word count. Okay, so that's the name of the class, and the master is going to be yarn client. Okay, and the jar file is going to be home Hadoop workspace target Spark, I think, right? Spark, yeah, target. Okay, and here we have Spark 1.0.0 snapshot. Okay, I say snapshot jar with dependency. So this is my jar file name, and the name of the input folder, okay, is slash. I called it as word count here. Okay, slash. The name of the output folder, I want to put it in the same word count, and I want to create a folder called as output here, right? So this is how I'm going to frame my Spark submit command. So I specified the name of the class and the mode in which I'm going to deploy this application on the Hadoop cluster, and then the jar file name, and then the input file name and the output folder path. Okay, so let's try to execute this and observe what happens. Something has gone wrong. Okay, so this Hadoop conf dir or yarn conf dir must be set in the environment. Okay, so that is what he's trying to say. So let's do that. I think that is missing here. Okay, so now let me open the bash rc file. So I'll say See, Hadoop needs, the Spark needs to know where is Hadoop services on this machine. Okay, that's so it is not finding that. So in our bash environment, also we should specify this Hadoop conf dir, right? So let me open that. I'll say sudo gedit dot bash rc home Hadoop dot bash rc 1 2 3 4 5 6. So let me just go to the end of the file. All right, so now I'll add a couple more exports here. So I'll say export Hadoop underscore conf underscore dir. Now that I'm going to set it to slash usr local Hadoop. I'll say etc slash Hadoop. So that's the Hadoop configuration files. So that should find, from those configuration files, where is all the Hadoop services configured. So similarly, I'll just specify this yarn conf dir also equal to the same thing, right? So okay, and I'll save this file and I'll close it, and I'll say exit bash so that all those changes are updated, the bash environments are updated. And now let me try to run this again. Spark submit. So if you observe, now the Spark driver is now it is completed the execution, right? So let us go back into our folders here, and let me update this and see what's happening. Okay, so if I go to word count, now you can see here underneath word count there is one more folder called output created, and within that output, okay, you can see there's a success file and there's a part file. So this part file is the result of your program execution. So if you look at this, now if you download this file, so this is your output of this word count. Okay, so now just open this somewhere. Now you can see the output of this word count program. So it is giving you all the distinct words followed by the number of times it is repeated.